Hello everyone, my name is Nur Atika and this is me. So today we will learn about Radioisotope Thermoelectric Generator, or also known as RTG. But first, what is RTG? Radioisotope Thermoelectric Generator, or also known as RTG, are devices that convert the waste heat given off by radioactive decay process into usable electrical energy. They produce electricity by the heat emitted from decaying radioactive isotope. RTG are often installed in space-bound objects that require energy and other remote structures or machines that cannot obtain energy efficiently by any other means. There are three components of RTG. The first one is isotope, the second one is thermocouple, and the third one is thermal insulation. Now, let's go to the first component of RTG, which is isotope. The radioactive isotope is a nuclear source that provides the heat from which the rest of the design produce electricity. Most designs use plutonium-238, strontium-90, and americium-241 for their power density, half-life, and radioactive shielding requirement. Because the half-life of the isotope are strategically chosen, RTG provide power for decades. One of these three isotopes will be deposited in pellets at the center of the RTG, to which they can decay and emit heat to the surrounding components. Next, let's go to the second component, which is thermocouple. Thermocouple is a device that can produce electricity by difference in surrounding temperature. Thermocouples for array of the thermocouples used to construct thermoelectric device to handle particle amount of power. Now, let's go to the third component, which is thermal regulation, or also known as thermal insulation. The use of thermal regulation is to maintain a certain temperature to keep electronics and movable parts operating properly. The RTG is covered with many layers of insulation and then a hard outer shell to protect the critical working of the device. So, how do the RTGs work? The first procedure is radioactive decay heat one side of a thermocouple, which is at 1. Then an electric current is produced on the opposite cooler side, which is at 2. Then tapered from terminal connected to the thermocouple at 3, and then producing power at 4. RTG work by converting thermal energy into electrical energy through devices known as thermocouples. The natural decay of plutonium-238 produce heat, then transfer one of the side of thermocouple. The thermocouples, which is at 3, produce electricity through the transfer of heat from the RPS to the cold environment of space, or the planetary atmosphere. Excess heat energy is used as a steady source to maintain proper operating temperature for the spacecraft and its instrument in cool environment. Have you ever think why we use plutonium-238? Plutonium-238 is the common and famous isotope used on NASA RTG. Has a half-life of approximately 90 years. Plutonium-238 is very powerful alpha emitter, as alpha particles are easily blocked. Plutonium-238 emits steady heat due to its natural radioactive decay. Now, let's take a look at the application of radioisotope thermoelectric generator. The first one is satellites, and the second one is remote lighthouse. Now, for the conclusion, we know that RTG are devices that convert the waste heat given off by radioactive decay process into usable electrical energy. RTG can be divided into three components, which is isotope, thermocouple, and thermal insulation. It's all about radioisotope thermoelectric generator, or RTGs. Thank you. Goodbye.